lesson, part 5, and today's topic is law of superposition of waves. Already we have studied this superposition in the previous lesson itself in oscillations. The same superposition of simple harmonic motions can be applied for superposition of waves. Here, superposition is mixing of two or more waves. What is meant by superimposed? What is this superimposed? What is the meaning of this word? Mixing together. So when two or more waves mix together with each other on a particle, then the particle will have a net displacement equal to algebraic sum of the displacements of the individual waves. So what is the meaning of this one? First let me explain the diagram, then we will read this one again. So this is a particle, a small particle, tiny particle. On this particle, one wave is coming like this. And this wave is hitting this particle. The mass of the particle is negligible here. So the wave energy is enough to push this particle down. At the same time, one more wave is, this is y1. What is the wave equation here? y1 is equal to a1 sine omega 1t minus k1x. This is the equation of the first wave. Now one more wave is coming in this direction. What is the wave equation here? y2 is equal, the amplitude is slightly different, sine omega 2t plus kx2, y plus here. Wave moving along positive x-axis, signs will be opposite. Wave moving along negative x-axis, signs will be same. So now, what happens to this that particle? If only green color wave is hitting, then what happens, students? It's a small particle, tiny particle. It goes down. Who goes down? This particle. But when the blue color wave is also coming, it will be pushed up. It will push it up. Let us say both are having same angular velocity and both are having same wavelength and same propagation constant. But their amplitudes are different. Where the amplitude of the green color wave, let us say 4 centimeters, and the amplitude of the blue color wave, let us say 10 centimeter. Due to this, whether the particle moves up or down, tell me. Up or down? Green color one pushing this down, blue color one is pushing this up. Green color pushing by 4 centimeters and blue color pushing by 10 centimeters. So what is the net displacement of this particle? Tell me. Net displacement is equal displacement of first one plus displacement of, because this is everything is same. There is no change in this one. Either in the phase there is no change, same, only amplitudes are different. Then what is the total displacement of this one? y1 plus y2 or a1 plus a2? Here what is y1? Nothing but a1. I will keep this down. Can I say minus 4? Green color pushing this down along negative y-axis and blue color pushing this up. So what is this? This particle moves up by, is it clear, students? It is just like pulling a person on both sides. If somebody pulling me on both sides, in which side I will move? Left or right? If both forces are equal, I will be in equilibrium. If this is 10 newtons, this is 4 newtons, then I will move this side by 6 only, right? This is 10, this is 4. So total displacement, total force acting on me, 6 only. The same thing what I am writing here. Now read the statement. Forget about more waves. First take 2 waves. If 2 waves mixing each other or superimposed with each other on a particle, the particle will have a net displacement y net. particle will have a net displacement equal to sum of displacements or algebraic sum. Why algebraic sum? Because these may be hitting in this direction, opposite, maybe in the same direction, or maybe at an angle. That's why algebraic sum. Best word, instead of algebraic, you can use a vector sum. Better, vector sum. So can I say like this? Y bar is equal y1 bar plus y2 bar. This is a law of superposition of waves. Clear, students? Now, this is a particle. One wave is traveling like this, not hitting this wave. This is y1, and one more wave. This is y2. Then what happens? Whether the particle goes up or down, because both are pushing this particle upwardly. So then also, what is the equation? Y net, y1 plus y2. Here also I did the same thing. Y net bar is equal y1 bar plus y2. Why vector sum? Because these waves may travel in any direction. One more example. This is one of the particle. One wave is coming like this. Ding, 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 ding. This is y1. And one more wave is coming like this. Ding, 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 ding. Now, here you can write y1 plus y2 directly. Here you can write y1 minus y2. What is this? y1 minus y2. Without sign. y1 minus y2 or y2 minus y2. There y1 plus y2. y1 plus y2. But here, this is y2. Then what you can write? Y net is equal to y1 bar plus y2 bar. y1 bar plus. Is it clear, students? Superposition of waves. Is it clear? Now, based on these waves of superposition, we can see three different phenomena in physics. Three different phenomena. So, what are those three different phenomena? Applications of superposition of waves. So, applications of law of superposition of waves. Applications of law of superposition of waves. First application, interference. What is the first application? Interference. Second application, stationary waves. Third application, beads. Third application, beads. These are the three applications, students. In first PUC, we will just learn about interference, not briefly, not in detail, but we will study about stationary waves. Tomorrow's lesson is only about stationary waves and beads. So these are the applications of what? Law of superposition. So today I will explain about interference, and tomorrow we will discuss about these two. Then lesson will be completed. Now, what is this interference? Students, interference takes place only between coherent waves. Which waves? Sir, what are these coherent waves? You told about longitudinal waves, transverse waves. You explained about mechanical, non-mechanical. You told about one-dimensional, two-dimensional, three-dimensional. Correct? We know only these. Now, already you told about progressive wave and stationary waves. But what are these coherent waves? These are not new waves. If any two waves have equal frequency, equal wavelength, automatically they will have equal velocity, because V is equal to F lambda. F and lambda both are same, then velocity must be same, and have zero or constant phase difference, constant phase difference, then they are known as coherent waves. So here I am drawing two coherent waves. See, this is the first coherent wave. This is Y1 students, Y1, and this is the second coherent wave. This is Y2. Can I call them as coherent waves? We will check first. First one, they have equal frequency, number of waves produced per second. Here 1, 2, 3.5 waves produced. Let us say this is in 1 second. Here also 3.5 waves. So frequency same. Wavelength, whether equal or different. Check once. Wavelength means from crest to crest only na. Is this same or different? For both wavelength is same. And the frequency same, wavelength same. They must have same velocity. Fourth one is most important. What is that? Zero phase difference. Zero. Both are starting from same point. After some time, both are ending at the same point. Correct? These are the starting points. These are the ending points. In same time. In same time. So can I say x1 is equal to x2? Distance traveled by first wave is equal to distance traveled by second wave. Artha agida? So what is the path difference between the two waves? They are starting here, just like you and our sibling, sister, brother, whoever it may be, akka, tangi, anna, tamma, yaro. When you are going to school, you are starting at the same time and you are reaching school at the same time, in general. In between ಏನಾಗಿದೆ ನನಗೆ ಗೊತ್ತಿಲ್ಲ, but in general you are starting at same time, you are ending here, you are reaching the destination at the same time. So what is the distance traveled by you? Let us say 40 meters. What is distance traveled by your sibling, your brother, your sister, your cousin, anybody? 40 meters only na, because both are traveling together. If waves are traveling, they will have zero path difference. Together they are traveling. So x1 is equal to x2. What is the change in the path traveled? Zero. Yesterday I gave an expression. Phase difference is equal to 2 pi by lambda into path difference. Delta phi is equal to 2 pi by lambda into delta x. This is 2 pi by lambda. What is delta x here? So what is the phase difference? What is phase difference? When two waves are said to be having zero phase difference, starting at same point, traveling equally, ending at the same point, then they are said to have zero path difference, zero phase difference. Clear, students? Now I will show one more wave here. You just tell me whether they are coherent or not. These are also coherent. These are also coherent. First we will check whether they have same frequency or not. To check this one, we have to count number of waves in a given distance. Here 3, here 3. So same frequency. In the same length, equal number of waves should be there. Okay. Wavelength, crest to crest, same or different? Velocity, if these two are same. Is it zero phase difference? No. First wave traveled less distance, second x1. Second wave traveled more distance. So x2 greater than x1. x2. So path difference is not zero. This is the extra path traveled by second wave. What is this? Extra path traveled by extra path. There is extra path traveled by the second wave. So delta x is not 0. So what is delta phi? 2 pi by lambda into delta x. Suppose if it is exactly 1 lambda, you write this delta x lambda, what will get? Lambda will cancel. What is the extra path? The extra phase 2 pi radians. Is it constant or varies? Constant. So what are coherent waves? What are coherent waves? Tell me. Two waves said to be coherent if they have equal frequency, equal wavelength, equal velocity, but most important, having zero or constant phase difference between them. Law of superposition of waves. The first one is interference of waves. Second one, stationary waves. Third one, beads. First of all, interference of waves. It is the superimposition of two waves which are different in phase. What is this? Superposition of waves differ in phase. Second one, stationary waves. This is superposition, means mixing only. Superposition of waves differ in direction. Third one, waves. Superposition of waves differ in frequency. First one, what is this different phase? Already we studied that interference takes place between two coherent waves. Either they are in same phase, slightly constant phase difference also, they produce interference. We will learn about this interference now. So here, waves which are having some constant phase difference, moving in same direction, generally moving in same direction, superimposed with each other, then interference will take place. Interference, students, suppose I lost 5 rupees coin in grass night around 10 o'clock. Now I am using my cell phone torchlight, which is not sufficient. I am searching for that one, but that light is not enough. Then if three of my friends came and they were also using their light, then intensity of light increases. Here what is happening? They are actually not coherent sources. Coherent sources means light or sound should be produced from the same source. But light coming from different cell phones is not coherent, but still all these waves are superimposing with each other. Then intensity increases or not? Just like floodlights in a cricket stadium. So lights are superimposed with each other, light waves. Here interference takes place between sound waves or light waves. Now when I am speaking, I am producing one sound wave. If some other lecture is also explain the same concept, or if two singers are singing same sound, then what happens? Whether intensity increases or not? So both sound waves are superimposing with each other, but they are not coherent. Why? Every individual will have a different frequency. I have my own frequency, some other person will have his own frequency. There will be slight change in frequency. Suppose if their frequencies are equal, then those two appears as a single sound, and that phenomena is called interference of waves. So in interference what happens? Intensity increases. Interference, intensity increases. Every time intensity will not increase. Generally intensity increases, but intensity may decrease also. It may become zero also. If waves traveling in same direction, intensity increases. Opposite, let us say this is 5 centimeters. Total intensity how much? Total amplitude 0 means total intensity how much? 0. It may be decrease in intensity or increase in intensity, but the redistribution of energy. That's why interference is called redistribution of energy due to superposition of coherent waves. So this is a phase change in birthday. Next, stationary waves. If two identical waves, stationary waves can be produced only due to two or more, but generally two identical waves. Two identical waves moving in opposite direction, not in same direction. Same direction, generally what happens? Interference. If these are coming in opposite direction, then stationary waves will be formed. What forms? Stationary waves will be formed. So there should come identical and opposite direction, moving in opposite direction, produce stationary waves. Tomorrow we will learn about the stationary waves. Third one, beats. When two waves all are identical, amplitude may or may not equal, but all are almost identical, not equal. Almost equal frequency. That means there is small change in frequency. Let us say frequency of one wave 200 Hz. Frequency of other wave 202 Hz. There are two waves whose frequency is different but almost equal, traveling in same direction. Then you are listening my voice, in between you are listening the sound from the fan also. These frequencies are different. If they are almost equal, what happens? Then you will hear waxing and waning of sound. Waxing means loud sound and then no sound, loud sound, no sound. You might have observed these beats in your life, but you don't know that they are beats. So tomorrow I will explain about these beats. So these are the three applications of law of superposition of waves, and today's topic is interference. So interference takes place between coherent sources or coherent waves. I should write coherent waves. So let us say there is a particle on which one wave is traveling and hitting, and another wave is traveling like this and hitting. So this is y1, this is y2, and the phase change between these two is phi, constant phase difference. Either zero phase difference or constant phase difference should be maintained. Now, where say y1 is equal a1 sin omega t. I am not writing that kx where x is equal to 0. I am taking the equation of the source. At the source x is equal to 0. So what is y2? a2 sin omega t plus phi. Slightly different phase. So see the first statement. What is the statement? Interference of waves takes place. It is due to the superposition of waves differing phase. Is there any phase change is there or not? 5 phase changes. Now, according to law of superposition, what is the net displacement of this particle due to the effect of these two waves? Tell me. y1 plus y2. So what you can write? a1 sin omega t plus a2 sin omega t cos phi plus cos omega t sin phi. How we got this formula? Sin a plus b is sin a cos b plus cos a sin b. So what is the resultant displacement of that particle under the action of two different waves? What is common here? Can I take sin omega t common? Sin omega t common, a1 plus a2 cos phi plus cos omega t a2 sin phi. Understood? I took cos omega t, a2 into sin phi. So this is the equation. Now in this equation I can write sine omega t. This I will take as r cos theta. R cos theta plus cos omega t r sin theta. R sin theta. Sin the sine of cos cos. Then I can write this equation as r common sin omega t cos theta plus cos omega t sin theta. So what is r? What is y? R sin omega t plus theta. This is the net displacement of the particle under the action of two waves. What is this? Net displacement. Net displacement. Here, what is this r? See the equation. Y is equal to a sin omega t plus theta. Amplitude. The resultant amplitude. What is this? How to find the r value? We know this is equal to this. This is equal to this. Write down. A1 plus A2 cos phi. How much? R cos theta. Correct? I assumed this as this. Similarly, I assumed A2 sin phi as A2 sin phi is equal to R sin theta. Squaring and adding. Tell me. Square this one. A1 square plus A2 square cos square phi plus 2A1 A2 cos phi plus A2 square sin square phi. Correct? Left side. A plus B whole square A square plus B square plus 2AB. This square is directly writing here. Right side. R square. Inni ide cos square 3 plus sin square how much? What is this value? A2 square. A2 square cos square phi, A2 square sin square phi how much? Just A2 square. So now what is R square, students? A1 square plus A2 square plus 2A1 A2 cos phi. So what is R? Already we studied this in a previous topic. SHM of two simple arc motions, superposition. So this is R. Now, if you see this one, this wave is coming in this direction, this wave is going in this direction, this is the phase angle, the resultant will be in this direction. So this is A1, this is A2, this is R. The same thing I am drawing here. This is A1, this is A2, and this will be R. And this is a phase difference between two waves phi. Now I want the angle between the resultant and one of the amplitude. How to get this value? Nenpidiya? Motion in a plane. If you extend this one and this one, tan theta is this by this. Tan theta is equal to, this is A2, this is phi. This is A2 cos phi, this is A2. So what is tan theta? Opposite side. A2 sin phi by A1 plus A2 cos phi. So theta is the angle made by resultant with a horizontal amplitude, which is equal to tan inverse A2 sin phi by A1 plus A2 cos phi. You put two different waves, y1, y2, coming from two slits, superimposed at a point P. What is the resultant displacement of this particle? Y is equal, y net is equal formula, y1 bar plus y2 bar, point number 1. Point number 2. After the superimposition of these two waves at the particle P, the particle P will have a different amplitude. The resultant amplitude, generally denoted with the letter R, but we can denote with A also. a1 square plus a2 square plus 2a1 a2 cos phi. And the phase of that particle due to vibration, theta is given by tan inverse a2 sin phi by a1 plus a2 cos phi. And the final expression y is equal to r alla beda, I will take a sin omega t plus theta. y1 is a sin omega t, this is also omega t only, alli phi ide illi theta ide, that is the difference. So these are the 4 points about interference. But the fifth point, the most important point, students, fifth point, if you observe this one, what is the intensity of the wave? Morning in the previous class I gave an expression for intensity, 2 pi square f square a square rho v, 2 pi square f square a square rho v. In this, students, the same expression what I am writing, intensity is equal k into a square. Why k? 2 is a constant, pi is constant, frequency is constant, density is constant, velocity of the wave is constant. If you combine all these constants, you get k. So intensity is equal to k into a square. Can I write intensity directly proportional to a square? Now a is equal to a1 square plus a2 square plus 2a1 a2 cos phi. Squaring on both sides, what will get? A square. So this after squaring, can I write like this? A square is equal to a1 square plus a2 square plus 2a1 a2 cos phi. Multiply k on both sides. What is k? 2 pi square f square rho v. That is k. So what we get here? K a square is equal k a1 square plus k a2 square plus 2 k a1 a2 cos phi. What is k a square? I. This is a resultant amplitude. This is a resultant intensity is equal I1 plus I2 plus 2 root I1 root I2. Why? You will see. If you take this equation, 2 root k a1 root k a2 na 2 k a1 a2 can witness 2 root k a1 root k a2. Root k into root k, k 2 a1 a2 a1 a2. So I is equal to k a square. What is I1? K a1 square, because k never changes. For I1 or I2, this term never changes. 2 pi square f square rho v never changes. So this is I1. Square rooting on both sides. Root I1 how much? Root k a1. This is what I am writing. 2 root k a1 plus 2 2. What is root k a1? Root I1. Root k a2. Cos phi. This is the fifth equation that we can derive from this. Already we derived this from law of superposition. This is, we derived the equation, then we found the angle, and this is the equation of the resultant wave. And the fifth one is intensity formula. How to get intensity? The total or net intensity or resultant intensity is intensity of first wave plus intensity of second wave plus 2 into root of intensity of first wave, root of intensity of second wave into cosine angle between the cosine of the phase angle between them. So this is resultant intensity. What is this? Resultant intensity in interference. Based on this intensity, students, interference can be divided into 2 types. One is constructive interference. Second one, destructive interference. We will see what is this constructive interference, what is this destructive interference. First one, left side I am writing constructive. Here destructive interference. So what is the constructive interference? Point number 1. Constructive interference takes place if two waves, current waves, moving in same direction, superimposed with each other, such that crest combines with crest, trough combines with trough, crest combines with crest, trough combines with trough. So when constructive interference takes place, when constructive interference, what is construction? Keeping one brick and then cement, one more brick, cement, one more brick, cement, one more brick. So we are increasing the intensity, we are increasing the height of the wall. Here also constructive interference means we are increasing intensity. We are destruction, smash, we are decreasing intensity. So in interference, generally intensity increases, at the same time intensity decreases. So destructive interference. So when constructive interference takes place, constructive interference takes place when crest of one wave, crest of one coherent wave superimposed with crest of another coherent wave. So when constructive takes place, crest combines with first wave crest, second wave crest combines together. Trough combines with trough, crest combines with crest, trough combines with trough. So here I can write it takes place or it produced. Okay, it takes place when crest of one wave combines with the crest of another wave, or second one, trough of one coherent wave, superimposes with trough of another coherent wave. Then we will get constructive interference. We will get constructive interference. When you get destructive interference, same ditto students, crest of one wave combines with the trough of another, or trough of one wave combines with the crest of another wave, you will get destructive interference. So here I will show the diagram. Second one diagram. This is the first wave. I will take this as y1. And as these are coherent, frequency same, wavelength same, speed also same. So one more wave is combining like this. This is y2. This is y2. So then what happens means we will get constructive interference. What is destructive interference? This is crest, this is trough. This amplitude is plus A, this amplitude is. So what is the total amplitude? 0. The amplitude 0 means intensity 0. That is called, this is the destructive. Constructive only, this amplitude A, this amplitude also A, total amplitude 2A. Both are in same direction, A plus A, 2A. Intensity 4A square. I don't know A square la. 2A whole square, K into A whole square, 4A square. Next, third point. Here I will write for third point. For constructive interference, third point. How to add amplitudes here? Can I say A is equal to A1 plus A2? Sir, there you wrote A is equal to, third condition students. Constructive interference takes place if crest combines with crest. When it is possible, 0 path difference. Both are starting at same point and ending at same point. Then zero phase difference. So what is the phase difference here? Phase difference. Phase difference for constructor difference. How much? 0. Only 0 or some other value? One more is there. Even the phase difference is 2 pi, 4 pi, 6 pi and so on. 2n pi. 2n. Then also we will get a constructive interference, constant phase difference. Destructive, third point. Phase difference, delta phi should be pi, between those two. That should be constant, pi. 3 pi, 5 pi, 7 pi, 2n minus 1 into pi. If it is the phase difference, then you will get a destructive interference. Why? We will see now. These are the conditions, but why it takes place, we will see. All I told you, constructive means intensity more or less. Destructive means less or 0. Less or 0, anything. Minimum or 0. Now see this one, fourth point. What is amplitude? Root over a1 square plus a2 square plus 2a1 a2 cos phi. But what is phi, students? 0, 2 pi, 4 pi. First I will take 0 only, easy calculation. What is cos 0? So what is the amplitude of the constructive interference? a1 square plus a2 square plus 2a1 a2. So a is equal to, can I say this is a square plus b square plus 2ab? a1 plus a2 whole square under root, cancel. So what is happening here? A plus a, 2a. Because this is a, total almost 2a. This is a resultant amplitude. Can I say AR here? Why AR? Resultant amplitude. This side, fourth point. What is the resultant amplitude? a1 square plus a2 square plus 2a1 a2 cos pi. But what is pi, students? Pi. So a resultant is equal root over a1 square plus a2 square cos pi. So I am writing directly 2. So what is the a resultant in destructive interference? a1 minus a2 whole square under root. This will become a1. There a1 plus a2 constructive, destructive a1 minus a2. And one more point, note we can write. Suppose if both are having same amplitude. So what is a resultant? This is a. How much? A plus a. This is 2a. If a resultant is 2a. This side you come here. What is a resultant? A minus a, that is 0. If a1 is equal to, this is special case. Generally we have to remember this one. This is a1 minus a2, that is a1 plus a2. Fifth one, most important one, intensity. So what is the resultant intensity? K into resultant amplitude square. What is K? 2 pi square f square rho v. We know that one, K value. So resultant intensity is equal to K into AR square. So what you can write? K into, what is AR square? This is AR. What is AR square? Squaring on both sides. A1 plus A2 whole square. Or if you take this equation, you can write this resultant intensity as, what is A1 square? Squaring on both sides. AR square is equal to A1 square plus A2 square plus 2A1 A2 cos phi. So what is KAR square? I. What is KA1 square? I1 plus I2 plus 2 root 2. I1 I2 cos phi. This is the resultant intensity. Now here, fifth point, resultant intensity. IR is equal to KAR square. This is from this k into a1 minus a2 whole square. From this, what is intensity? Result intensity. What you can write? I1 plus I2 minus 2 root I1 I2 cos. When intensity will become 0 into I 2I 0 ಆಗುತ್ತೆ ಆಗುತ್ತಾ? ಹಾಂ, ಕಾಯಿಸ್ತಾ ಬೇರೆ ಕಾಯಿಸ್ಬೇಕು. So if I1 is equal to I2, what is resultant intensity? How much? If I1 is equal to I2. Here, if I1 is equal to I2, the cos is not required. I plus I, 2I. This is another 2I. Total? Not 2I. That means if two waves of intensity I and I superimposes, total intensity is not 2I. This will become 4I in interference. Remember this. 4